Alright, so here we are showing the DK alternator power hub, and I know that this is kind of hard to take in all at once, but what we're doing right now is we're putting in a little bit over 24 volts and about 0.5 amps. We're actually drawing about that because it shows that on this shunt meter. But we have the input power from a DC power source feeding here, and then we have our external charging system set up, and this is what it's pulsing out, about 300 milliamps there in a pulse discharge. Here we're putting out about the same, probably 400, and on the back EMF circuit slightly higher. Now what we're going to do is we're going to, as we're here, we're at 100. So we're going to increase the pulse width modulation, and you'll hear that it's speeding up because we're now increasing more voltage that is going to be going into our discharge cap. This is the blue circuit, this is the green circuit, and this is the yellow circuit. Up there corresponding, we have a 2 ohm load on the yellow circuit, 2 ohm load on the yellow circuit, and the blue circuit is over there, same load. So now you can see that we now have reduced our draw. Now if you look on the DC indicator, we're down below 4, and here we're hovering or down below 5, and we're down below 5 here. So that's what I wanted to show you to start with. And let's take a RPM reading to see what we've got in RPMs. And right now we're putting out about 489 RPMs. Now as we increase the voltage, we will increase the RPM. So as we take this up and increase the amperage, we're up to 27, 28 volts. And now we're increasing the amount of what we can put out in discharge into our charging caps, which as it loads, it's up over 400 milliamps. Here if you look at it, it's up over 500. It's up over, say, 600 on the pulse, which also increased the voltage that goes into these caps that I will also show you on the video. Our draw now is up over 600 milliamps, so we're still way less than an amp of input, and we're putting out well over amps of power in DC pulse. These are our bypass filters that shields as the load increases, because we still have the standard 2 ohm load on these sand resistors. And that's all I want to show you for now. That's our setup. This is where we run our DC to AC power inverters. So we run that wire up, and that goes over to our box, way over there, our panel. And we've run some manual switches so that we can switch and control different circuitry in our home for running different types of tests. So we've got these switches that we can switch manually for backup battery power versus straight AC power coming in. We have a large inverter switch that we're going to eventually use, which is Thompson technology, and we've built a Greenwise home that gives you an idea on what we believe that we can do with this type of an indicator. My workbench is a mess because I'm a busy guy. These are things that we've done. These are the batteries that we can use, our deep cycle batteries. There's the capacitors we have in front of those batteries that increases the charge. So now we decrease back down our voltage and take it back down to 24 about, and you can see that our draw goes back down respectively. That's our input. and our output follows the same, but we're now putting out about 300 milliamps, and that's not at full power. We take this up to 300 by increasing our voltage here and take this all the way up to 30 volts. You can see now that we're putting out well over 600 milliamps. We are now going to be we're at 600. We're at about 619, 623, 687, 617. I can't seem to hold it on there. 622 RPMs, and we're putting out a considerable amount, which is going into our charge caps. And you see now that our charge going into there, if it unloads, is well up over 400 milliamps there. That is our back EMF circuit. I don't like to run it up there very long because my circuitry is not set up to do that. And we will end this right now, just showing you this is a magnet over coil setup, which we can remove this entire setup on the top and have this running the input off of the flywheel or generator or solar panels, etc. So that's the DK Power Hub.